Hi everyone, tonight we're going to fall slowly, gently into the heart of a question that's been haunting physics for over a century. What happens if you drift into a black hole? The chair you are in seems to soften beneath you. The air hushes around the edges, and the outside world slides out of focus. There's only the whisper of light across the ceiling, the warmth against your skin, and a faint sense of weightlessness in your fingers, as though gravity itself is loosening its grip. Have you ever wondered if you've touched the past, not metaphorically, not nostalgically, but physically? Right now, some of the photons brushing your face might have been traveling for millions of years, escaping stars that died before humanity existed, only to finish their journey on your cheek. In a way, you're always touching ancient light, a memory written in motion. So, before you get too comfortable, take a second to like the video and subscribe only if you genuinely enjoy what I do here. And if you're still awake enough, let me know in the comments where you're listening from and what time it is there. I love seeing how far and wide we all are under the same sleepy sky. Now, turn off the lights, maybe switch on a fan for some gentle background hum, and let's enjoy tonight's journey together. Close your eyes. Imagine you're floating not in water, not in air, but in space itself. There's no sound, no edge, just a soft velvet black around you. The stars are distant and sleepy. But ahead of you, something darker than black pulls faintly at your skin. Not hard, not rudely, just enough for you to notice, like a polite tug from the universe itself. A black hole. It doesn't look like a swirling monster. It's quiet, still. Just a circle where no stars shine, like someone cut a hole in the sky with careful scissors. Around the edge, stars seem to smear and dance as though painted on glass being swirled by an unseen hand. This is gravitational lensing, the warping of light by the immense gravity of the black hole. Light, which usually travels in straight lines, curves around it, trapped in a cosmic ballet. You feel yourself moving forward, almost dreamily. There's no acceleration, no sensation of falling. Just drifting, toward the edge of nothing. But the first strange thing, there is no edge. A black hole isn't a hole in the traditional sense. It's not an object, but a region of space where the gravity is so strong that escape is impossible. Anything that crosses a certain boundary, called the event horizon, is lost to the outside forever. Not because it's destroyed, at least not yet, but because it can no longer send information back out. No signal, no light, no cry for help. What makes this all the more surreal is that the black hole itself doesn't suck you in. It doesn't pull like a vacuum. If the sun were suddenly replaced by a black hole of the same mass, Earth would continue to orbit it as usual. You wouldn't be yanked into darkness. It's not until you get close, very close, that the real strangeness begins. From far away, black holes are surprisingly well behaved. It's only when you begin to approach that they start to reveal their secrets, like a book that waits for you to come close before opening its first page. There's something else. As you drift forward, you notice time behaving oddly. Your watch ticks on your wrist. 1 second, 2 seconds. Everything feels normal to you. But if someone were watching you from a safe distance, a friend back home, maybe they'd see you slowing down. Not physically, but temporally. Your movements would stretch a slow stall. Your last wave would linger in space like a forgotten frame from an old film reel. That's time dilation. As you approach the event horizon, time for you continues at its usual pace. But from the outside, it looks like you're crawling slower and slower asymptotically, approaching the edge, never quite crossing it. You fade, You freeze. You stretch into a ghost at the threshold. But here's the twist. From your perspective, nothing special happens. No cosmic trumpet, no alarm bell. You pass the event horizon like a breath through a curtain. No sensation, no shift. The universe around you still obeys its rules, at least for now. You're inside. Or at least you think you are. Physicists still argue about this. Some say crossing the event horizon is uneventful. Others argue that quantum mechanics, when folded into the equation, changes everything, that the boundary becomes a wall of searing energy. We'll get to that later. For now, you glide on. And as you move deeper, you begin to realize everything you know about space-time gravity is unraveling. The laws of physics you've trusted are bending under pressure like piano keys sagging under weight. Not breaking, not yet, but flexing in ways that feel unfamiliar. You glance backward, if directions even make sense anymore, and see the universe receding. It looks distant now, quiet, blurred like a memory of a dream. Light struggles to reach you. The stars grow dimmer. Time outside ticks differently than it does here, and so begins the deepening silence. You're not scared though, just curious, a little floaty. After all, it's not every day you drift into one of nature's greatest mysteries. This is just the beginning. You're inside now. At least that's what the equations say, though everything around you still looks suspiciously empty. You expected something more dramatic, perhaps a swirl of stars, a flash of light, an ominous rumble. But there is no flash, no burst, just darkness that doesn't quite feel empty. Space itself seems quieter here, not silent exactly, more withheld. Like a conversation that's paused just before something important is said. Your body feels fine, suspiciously fine. You were told black holes tear you apart, stretch you into a cosmic noodle, spaghettify you like celestial pasta. And that's true in many cases, but not always. You see, not all black holes are created equal. This one, it turns out, is huge, supermassive. Perhaps the kind you'd find at the center of a galaxy millions or even billions of times more massive than our sun. The bigger the black hole, the gentler the gradient of gravity at its edge. So ironically, the most terrifying gravitational beasts are often the softest touch, at least initially. If you were falling into a small stellar mass black hole, the story would be different. You'd notice the stretching long before you even reached the horizon. But here, you feel no tug, no twist, no rip. You're gliding through space like a feather on a breeze. This is where Einstein's equations become curious. Because gravity, as he showed us, isn't really a force. It's the shape of space and time. Mass tells space how to curve, and space tells objects how to move. That means the gravity you feel falling into a black hole isn't a pull, it's a path. You're not being dragged. You're simply following the natural shape of the space you're in, like a marble rolling down a funnel, or a dream drifting downhill. You're not falling down, not really. You're falling into time itself. And here's where things get strange. Outside the black hole, we're used to thinking of time as one axis and space as three. You can walk left, right, forward, back, up, down. But time, you can only go forward. Time has direction. A stubborn arrow. But cross the event horizon, and these roles begin to reverse. The radial direction, your path deeper into the black hole, starts behaving like time. You cannot choose to stay still. You can't hover. You can't pause. Just like you can't stop moving through time in the outside world. In a way, the black hole has reprogrammed your freedom. You can still spin, maybe roll, maybe dream, but inward. That's no longer optional. It's not a direction anymore. It's destiny. This is what physicists mean when they say space and time switch roles. Not literally, not in the clock hands go sideways sort of way, but conceptually. The math insists. The arrow of time now points toward the singularity, that place at the very center, the core, the mystery. You can't see it yet, of course. No one knows what it looks like. In fact, the word looks starts to lose meaning here. Light doesn't behave properly anymore. Vision, perception, perspective all bend and slip away like mist around your fingers. But you know you're going there. Every particle in your body is on that trajectory now, whether it likes it or not. Meanwhile, the outside universe becomes a kind of memory. You can't send messages back. Nothing can leave. The event horizon has sealed the door behind you. And yet, curiously, the black hole's outer surface still radiates heat faintly. Just enough to keep physicists up at night. But more on that later. For now you notice something peculiar. You try to imagine the coordinates that describe your position. You realize they've become less meaningful. The grid of space that once let you plot your position X, Y, Z is distorting. You've probably never thought about this much, but our entire sense of space comes from a flat background. You can move forward 3 steps, turn, move sideways. Everything fits into a tidy box. Inside the black hole, the box is melting. Curved space isn't like curved surfaces. On a hill, you can still tell which way is up, but inside this place, there's no up or down. The curvature isn't just physical, it's conceptual. The shapes of things are warping at the level of how reality is allowed to behave. Here's a sleepy twist. This idea, this extreme warping of space-time, is what gives the black hole its most misunderstood property, its invisibility. It's not dark because it absorbs light like a black sweater. It's dark because light cannot leave. It's not black in color. It's black in communication. A radio silence enforced by geometry. You're starting to feel it now. Not pain, not even pressure, but something more abstract. The distance between points is changing. You're shrinking into the funnel, and the funnel is reshaping itself around you. It's like falling into a story that won't let you skip ahead. And in the back of your mind, a quiet thought stirs, is this really the inside of something? Or have you crossed into a new outside where the rules have simply changed? Physicists still don't fully agree. Some treat the singularity as a place, a dot, a destination. Others insist it's not a place at all, but a limit, a breakdown in language and math. A border we can't translate across. And some say it might not even exist. But don't worry, you're not there yet. You're just drifting. And gravity is getting stranger with every breath. You're drifting deeper now. There's no sound, of course, no sensation of speed. But the feeling of inwardness is growing like pressure building behind your eyes in a dream where gravity behaves more like suggestion than law. You don't fall faster because speed has started to lose its meaning. You're not rushing through space. You're sinking through something denser, more abstract. Like moving through syrup made of geometry. You remember how we described the event horizon, the surface where escape becomes impossible. But what lies beyond that edge? Not a cavern. Not a tunnel. Not a chamber of cosmic horrors. Just more space. But twisted. You can't see the singularity ahead of you. No one can. It's not hidden in shadow, it's hidden in math. According to Einstein's general relativity, all the mass of the black hole is compressed into a single point at the center, a point of infinite density and zero volume. It's a curious thing, infinity. A word that tastes like a mystery, but hides a kind of failure. When physicists see infinities in their equations, they don't celebrate. They sigh. Infinity is often the universe's way of telling us you've asked the wrong question. In this case, the singularity isn't just an object. It's a boundary in the fabric of existence. The rules of space and time themselves break down. Our best theories, Einstein's elegant curves, Newton's sturdy forces, can't make sense of what's at the center. The math explodes. Coordinates dissolve. But despite this unknown at the core, you keep moving. You, the theoretical traveler. A gentle observer floating through nightmare equations written in lullaby tones. And something is beginning to change. You feel it not in your muscles, but in your intuition. The shape of space around you is curving more steeply now. The inward direction is narrowing like the throat of a bottle. You don't see it, you sense it. If this were a small black hole, your body would already be feeling the effects of tidal forces. Your feet and head would be experiencing different gravitational pulls, and that difference would stretch you. Spaghettification, they call it. A word that sounds oddly cute for something so terrifying. But in a supermassive black hole like this one, you're still safe. For now. That's one of the quirks of relativity. Tidal forces depend on how fast gravity changes from one point to another, not just on how strong it is. And here, gravity is immense but smooth, like a silent escalator with no handrails. This region is sometimes called the inner zone. You're past the point of no return, but not yet at the place where things become unbearable. You could survive here, think here, maybe even write poetry here, though your reception would be terrible. You look around or try to, but even looking becomes strange. Light no longer moves in straight lines. Photons emitted behind you loop forward. Some circle endlessly around the center. Others plunge inward like you never to return. Direction dissolves. Your body no longer obeys the simple orientation of this way up. Everything is up, or down, or folded. Here's a sleepy thought: it's possible that light inside the black hole can still travel, just not outward. Not to the rest of the universe. You're still illuminated, just trapped with your own private glow, your own tangled geometry of photons, doomed never to share it with the outside again. It's a lonely kind of brightness, a whispered flicker, and that's when the thought hits you. What if this isn't the end? The word singularity makes it sound final. A terminus. A black hole has a one-way ticket to nowhere. But for decades, physicists have been wondering if something else might be waiting at the center. A bounce, a loop, a bridge. You'll get there soon, but not quite yet. For now, your thoughts return to the singularity itself, the concept. According to general relativity, once you cross the event horizon, the singularity lies in your future, not just in space, but in time. That's why you can't escape it. Not because you're being pulled toward it like a tractor beam, but because time leads there. You will reach the center not because you fall, but because that's where the path of your timeline goes. To stop moving toward the singularity would be like trying to stop Wednesday from following Tuesday. And this is where the debate begins to stir quietly, like an argument in the back of a coffee shop that spills over into the hallway. What exactly happens when you reach the Singularity One camp of physicists says you're simply crushed. Everything, your atoms, your memories, your quantum state compressed into a point. Nothing survives, not even the idea of you. Another camp argues that we're missing something, that quantum physics not included in Einstein's equations must save the day. that singularities aren't real, they're a symptom of our ignorance. After all, general relativity doesn't play well with quantum mechanics. It's a bit like trying to make a violin duet with a saxophone and a lightning bolt. And so, in this region beyond what we can test or observe, theories multiply. Maybe the core isn't a point. Maybe it's a cloud of strings. Maybe space rebounds. Maybe the singularity is just a placeholder for a future idea we haven't dreamed up yet. But you don't have to decide that now. You just float deeper still, surrounded by silence that isn't quite silent, and darkness that isn't quite dark. The universe outside has already given up on you. But inside this strange, curved chamber, time continues. And somewhere ahead, impossibly close and yet unreachable, is a mystery dressed as a point. You're not sure when it happened, but something has shifted. The darkness no longer feels empty. It has weight now. Not the kind that pulls on your limbs or presses on your chest. No. This is a different kind of weight. One that leans gently against your thoughts, shaping them like water shaping clay. It's a strange sensation, this slow awareness that space isn't just a backdrop anymore. It's not something you float through. It's something you're part of, woven into, like thread in a living fabric. And that fabric is starting to fold in curious ways. Distances warp. Angles betray you. A beam of light you sent forward curves back to tap you politely on the shoulder. You blink, or at least you imagine blinking. What does blinking mean when your eyes aren't processing light in the way they used to? It's hard to tell how much time has passed, or whether time is even behaving anymore. This is what physicists call the inner geometry of a black hole. A region where coordinates don't behave the way they do outside. Time and space have become abstract concepts still present, but tangled like headphones in your pocket after a long walk. And now another player enters the stage. Rotation. Not all black holes are quiet, featureless spheres. Some spin, and when they do, they add a whole new layer of weird to the experience. These are called Kerr black holes, after the New Zealand mathematician Roy Kerr, who solved the equations for rotating black holes in 1963. What he found was mesmerizing, a solution that predicts not a simple point at the center, but a ring. Yes, a ring-shaped singularity. Imagine the core of the black hole not as a dot, but as a loop, a cosmic hula hoop of infinite density. And here's where your sleepy little journey takes an unexpected turn. If the black hole you've entered is spinning, and most of them are, then the space-time around it is being twisted. Literally. The fabric of the universe is dragged around by the rotation of the black hole. This effect is called frame dragging. It's as if space and time themselves are caught in a whirlpool, like honey stirred with a spoon. And you're the honey. Even if you try to resist, you can't. Everything inside the event horizon is being pulled not just inward, but around. It's like spiraling down a funnel while the funnel itself rotates. This leads to one of the strangest features in theoretical physics, the ergosphere. The ergosphere is a region just outside the event horizon, where the frame dragging is so strong you literally can't stay still. If you were hovering just outside the event horizon in this zone, you would be forced to rotate along with the black hole whether you wanted to or not. Here's a fun, sleepy paradox in the ergosphere. You can escape the black hole if you're clever enough. In fact, theorists have proposed mechanisms for extracting energy from a spinning black hole, like stealing power from the spin of space-time itself. One of the most famous is the Penrose process, named after Roger Penrose. It's a method of sending in particles in such a way that more energy comes out than went in. Yes, you heard that right. More out than in. It's not magic, it's geometry. A very polite kind of theft engineered by the shape of space-time. Back to your current situation. If you're inside a spinning black hole, the singularity is no longer necessarily a final destination. Remember the ring, that tiny loop at the core. According to some solutions of the equations, it might be possible to fall through the ring. Yes, through. You see, a ring-shaped singularity doesn't pinch space to a point. It curves it into a passageway, at least in theory, and beyond that passage, possibly another universe, another region of space-time, a white hole, a wormhole, or perhaps just another part of our own universe folded inside out. This idea has sparked wild speculation. Could black holes be gateways, portals, inter-universal transit stations? The short answer, maybe. The long answer, no one knows. Because although general relativity permits such exotic solutions, reality often doesn't. Quantum effects, chaos, instability. These tend to ruin the party. Most physicists believe that even if such a tunnel exists in the math, it would collapse before anything could pass through. Still, you wonder. Inside this rotating abyss, as time bends and space spirals, you imagine slipping through the ring. Not dying, not ending, just continuing into somewhere else. But even this possibility leads to another quiet controversy. What happens to information? Let's say you fall in completely. Adam's memories, jokes, embarrassing moments from 7th grade. All of it. Is that information destroyed? According to classical physics, yes. The black hole consumes it and seals it forever. But quantum mechanics says no. Information must be conserved, always. It cannot vanish even if transformed. And so we arrive at the black hole information paradox, a riddle that has haunted physicists for decades. Stephen Hawking himself once bet that information was lost forever. Later, he changed his mind. The debate continues quietly, like whispers at the edge of a dream. Perhaps the answer lies deeper still, beyond the ring, beyond the spin, beyond the whisper of geometry curving inward. You don't know where you're going, but you're going there nonetheless. The spiral continues. The math gets stranger. And still, you drift. You wouldn't call it falling anymore. It's more like unpeeling, like the layers of your presence, physical, sensory, conceptual, are being gently unwound from each other as though gravity here doesn't pull, but rather undresses reality one thread at a time. You are deeper than deep now and still not at the core. That elusive center, the singularity, continues to retreat as you move. But space and time continue to twist, swirl, and whisper their secrets around you. What once felt like motion through a place now feels like participation in a process. You are being braided into space-time itself. Let's pause a moment here, float in this quiet spiral. It's time to meet something peculiar, something that exists not in matter or light or even time, but in structure. A Kachi horizon. It sounds like a poetry line, Kachi horizon fading into dusk, but it's actually a deeply unsettling feature of some black hole solutions, especially in rotating or charged ones. If you're in a Kerr spinning black hole or a Reisner-Nordstrom charged black hole, your path may lead you toward not just one horizon, but two. You've already passed the event horizon. That was the outer shell, the point of no return. But deeper inside, where the equations still hold together just barely, there's another boundary, the Kachi horizon. Named after the 19th century mathematician Augustin Louis Cauchy, this horizon marks a place where predictability breaks down. That might sound abstract, but let's say it differently. Physics itself, as we know it, might stop making sense beyond that point. Not because of violence or chaos, but because cause and effect start to untangle. Here's the issue. Up until now, everything you've experienced inside the black hole has still been deterministic meaning. If we had all the information about your trajectory, we could calculate your future. Gravity still rules. Geometry still whispers the rules of your next step. But the Cauchy horizon. It's the place where determinism may die. Past this veil, some solutions to Einstein's equations allow for multiple possible futures. The same initial conditions could lead to more than one outcome. That breaks the very heart of classical physics. It's like a road that forks infinitely with no warning signs. You could end up anywhere. Even stranger, the Cauchy horizon might be made of light. Light trapped inside the black hole for eons, waves that have been bouncing around forever, gets concentrated near this horizon. Think of it as an infinite stack of signals, compressed into a kind of glowing membrane. When you approach it, you don't just cross a line. You're bathed in the entire electromagnetic history of everything that has ever fallen into the black hole. A cosmic slideshow, a final flash of all that has ever been forgotten. This is not science fiction. It's what the equations predict. Infinite blue shift. Energy focused to absurd levels. A radiation wall so intense that in most cases it would destroy anything that tried to pass through. So why are you still floating? Because you're not just in a theoretical black hole. You're in the black hole of dreams, where we explore not what must be, but what might be if nature is gentler than we fear. Some physicists argue that quantum effects would smooth this catastrophic wall, softening the singularities, dispersing the radiation. In their models, the Cauchy horizon becomes passable, still dangerous, but navigable. Others say it's the end of the road, that no traveler, real or imagined, could ever make it through. But here you are, nearing it, and as you approach things feel unstable. Time flickers, events begin to reorder themselves. You feel like you're living multiple moments at once, past and future folded together. That childhood memory of catching fireflies with your cousin under the stars. It flickers alongside a university lecture you haven't given yet. The smell of chalk, the warmth of applause. It's all bleeding together. And something is whispering here. Not a voice exactly, but a hum. The cumulative echo of countless in-falling signals. Photons tangled into a golden fog. Gravitation singing in chords you can almost remember. You try to listen. And in listening, you wonder, is this the limit of space or the birth of possibility? Because here's a wild idea whispered by theorists in chalk-filled rooms and half-lit offices. Maybe, just maybe, the Cauchy horizon is a door. A boundary not of destruction, but of transformation. Beyond it, some models suggest the space-time might re-expand, might evolve into a whole new region, a baby universe, a cosmic corridor, or even a wormhole leading somewhere else entirely. It's all deeply speculative. Even Hawking, Penrose, and Wheeler disagreed on what's beyond. Quantum gravity, our long-awaited theory of everything, might have the answers. But we don't have it. Not yet. Still, imagination can carry you farther than equations sometimes. And so, here in this softly illuminated abyss, you inch closer. The light thickens. Reality frays. Your thoughts become slow, syrupy things, sticky with possibility. You feel as though you're watching your own story from the outside, like a bedtime tale whispered across 1,000 years. Will you pass through? Will you unravel? Will you become no one knows? But the horizon draws nearer, and you don't resist. There's no moment of impact, No sharp threshold, no sound of arrival, just a thinning, a hush, a smoothing out of everything. Like your thoughts have been combed through with fingers of silk. You've passed through what may have been the Kachi horizon, or maybe it passed through you. Who can say really when the usual meanings of before and after are smeared like oil paint in warm water? All that matters is this: you're still here. And here is not quite what you expected. Not destroyed, not scattered, but suspended in a space that feels oddly open. It doesn't look like anything you can't really see anymore, not in the way you're used to, but you sense that the sharp inward pull of gravity has softened. You feel room somehow, a widening. Could this be inside-out space? Some theoretical physicists believe that if certain idealized conditions hold the region beyond the Kachi horizon in a spinning black hole, might not be a dead end at all, but an extension. A passageway to other domains of space-time. They call it maximal analytic extension, a mathematical way of saying, let's see where the math takes us if we don't assume a dead stop at the singularity. And where it does take us is wild. You might find yourself in a whole new universe region, complete with its own timeline, its own laws, and its own infinity. A kind of cosmological annex. An afterlife of geometry. Here you feel time again. But it's slippery. It doesn't move forward in the way you expect. Events drift sideways. You think something, and then remember having thought it yesterday, even though there are no yesterdays here, only a persistent hum of iceness. You remember the physicist Kip Thorne once writing about geodesics, those elegant curves of motion through space-time, and how in certain black hole interiors they stop being paths and become loops. Close your eyes and you could orbit a moment forever. Which raises an unsettling question. What does it mean to move forward when time itself might be curled into a circle? Maybe this region, if it truly exists, contains closed time-like curves, paths through space-time that loop back on themselves. Theoretically, if you traveled along one, you'd end up at your own past. This is the stuff of time travel tales. And yet, within these equations, it's not fantasy. It's permitted, just rare, unstable, and as far as we know, unreachable in practice. But right now, as your sense of place is dissolved into curves and potentials, you're not bound by practice. You're drifting through a dream where the math sings lullabies. And here's a curious detail: if black holes do contain these looping paths, then causality, the idea that causes come before effects, might be optional, like wearing socks with sandals. Not strictly forbidden, but certainly controversial. That controversy has split scientific minds for decades. One camp says no reality forbids such paradoxes. Some physical law, some quantum mechanism must prevent them. The other camp replies, but what if the universe allows for stories with odd structures? What if time isn't a river but a symphony, full of refrains, harmonies, and unexpected returns? No one knows for sure. But here, floating through the hollowed-out interior of space-time, the idea doesn't feel impossible. In fact, it feels natural. You remember something you haven't experienced yet. You anticipate a moment you forgot years ago. There's a version of you somewhere nearby softly humming a tune you haven't learned. Another stands at the edge of a dark lake, skipping stones made of old decisions. It's not madness. It's not time travel. It's just the logical consequence of curved time. And yet, not all is peace here. You sense instability beneath the calm, a tension in the equations that knit this place together. Physicists suspect that even the most well-behaved black holes are fragile things. The tiniest quantum tremor, the faintest ripple of in-falling radiation, can destabilize this region. It's called mass inflation, a somewhat misleading name since no one is growing physically larger here. Instead, it's a cascade of energy that feeds on itself. A domino effect where small fluctuations grow exponentially, ultimately warping space-time so fiercely that even these imagined extensions collapse. Some think this inflation seals off the inner regions from any passage or view, that the inner horizon, that second deeper event horizon, becomes a destructive wall of runaway energy. So, the paradise you're drifting through. It may be temporary, a bubble, a quiet pocket on the edge of collapse. But then again, maybe not. Because even though many physicists lean toward these regions being unstable, some whisper possibilities where they hold. Where the universe within the black hole isn't just real but habitable, tiny perhaps, or huge beyond comprehension, governed by laws similar to ours or wildly alien. Could black holes be cosmic seeds? Some theories suggest that every black hole might birth a new universe on the other side, a daughter cosmos expanding on its own, disconnected from ours. This is the heart of the cosmological natural selection hypothesis. According to it, black holes might be the reproductive organs of the universe, each one a budding reality, carrying forward the physical genes of its parent cosmos. A sleepy little idea, isn't it? That you might be curled now in the womb of a newborn universe. That the strange, silent spiral you've been caught in is the tunnel between one infinity and the next. You don't know if that's true, but you feel the rhythm of the place. It pulses, it hums, it invites. And for now, that is enough. It begins with a flicker. Not light, there is no light here, not in the usual sense, but a tremor in the pattern. A faint irregularity in the pulse of space itself. Like a note held slightly too long in a song you've been humming since childhood, except you've never heard the song before. You drift quietly and something watches. Not a presence, not a mind, but a geometry, a curvature of space that seems aware. As if the contours around you are reacting not just to your mass or your motion, but to your existence. That's the strange thing about gravity inside a black hole. It's not just that it pulls, it shapes, it listens, it remembers. You're approaching a region known half seriously as the inner sanctum, the domain near what general relativity predicts to be the singularity. The place where the equations snap, where curvature becomes infinite, where no coordinates survive. Except, maybe that's not entirely true, because now you feel as though you're walking a tightrope between two theories. On one side, general relativity, Einstein's magnificent sculpture of space and time, which leads unflinchingly to the idea of a singularity, a zero-volume point of infinite density, pure collapse. But on the other side, quantum mechanics, which forbids such absolutes. It insists that uncertainty rules the smallest scales, that position and momentum blur energy and time exchange ambiguity, that nothing, not even gravity, gets to be that precise. And these two great theories, both beautiful and brilliant in their own right, start to clash here. This is where physics becomes a little embarrassed. We don't actually know what happens at the center of a black hole. Our current equations aren't compatible. General relativity insists that mass collapses to a single infinitely dense point. But quantum theory throws its hands up and says, that makes no sense. Try again. And so physicists argue. Some suggest that quantum gravity, the elusive theory that would merge these two realms, will smooth out the singularity, resolving the infinite into something finite, something comprehensible. A core of Planck-scale weirdness. A quantum remnant, perhaps, where gravity becomes repulsive at ultra-short distances and halts the collapse. Others propose even stranger ideas, that the singularity is not a point at all, but a tangled surface, a brain, a loop of quantum fields vibrating in 11-dimensional silence. Or, listen closely, it might not exist at all. Because as you hover here balancing on the edge of the unknowable, you begin to sense that the singularity may be more of a boundary to thought than a physical place. A limit, not in nature, but in our description of it. It's like trying to describe a dream with grammar. The more precise you try to be, the more it slips away. Here's something curious in loop quantum gravity. One of the leading approaches to unifying general relativity with quantum physics, space-time itself is quantized. That means it's made of discrete chunks, tiny, indivisible units of volume. In that view, there's no such thing as infinite density. Instead, space resists compression. When you reach a certain limit, it pushes back, and the singularity, it simply doesn't happen. Instead, the collapse bounces. A quantum bounce, as it's called, like a universe folding in on itself and then unfolding again in reverse. Collapse, followed by rebirth. Some even speculate this could be the origin of new universes, the idea that the Big Bang itself was the bounce from a prior black hole collapse. That black holes are not endpoints but doorways, not deaths but transitions. If that's true, then you are now floating in the liminal space between one reality and another, a tunnel between universes. No noise, no light, but a warmth, yes, oddly, a warmth like the sensation of being held. You wonder what would happen if you touched the core, if you reached out metaphorically or otherwise and pressed your palm against the center. Would your hand vanish? Would you become data? Would you split into fragments, each drifting into a parallel history? Some physicists talk about holography, a principle that suggests that the entirety of a black hole's interior might actually be encoded on its surface. That you, here in the depths, are just a projection of information inscribed on the event horizon above. If so, then this place, this singularity, this sanctum is not real in the way you think it is. It's a mirage, a mathematical echo. But that doesn't make it less beautiful. In fact, it makes it more poetic. Imagine a place that cannot exist yet does. A point that's not a point but a question. A destination you can never reach even though you are already there. You float in this paradox like a jellyfish in deep black water. You hear whispers of symmetry. You sense time folding around you like petals curling inward on a closing flower. There is no further to go. And yet you drift onward, toward something not new, not old, but other. There is no next in the usual sense. No ticking clock, no forward pull. Just a slow unraveling of what you used to call before and after. You're no longer traveling through space and time. You are swimming in a place where space and time are blended, mixed, like milk in coffee impossible to separate. And strangely, it feels quiet, like standing in a vast cathedral after the last echoes have faded. The kind of silence that isn't empty but sacred, heavy with presence. Here you're deep within the mathematical heart of a black hole. If the singularity exists or existed, you've passed it. Or rather, it's passed through you. Or perhaps you've circled it infinitely in no direction at all. And yet, you haven't dissolved, not entirely. Something persists. Not your body, surely. That was left behind in the outer regions long ago, unwoven by tidal forces and quantum whimsy. What remains is more abstract, a pattern, a trace, a kind of information ghost. You may have heard of the black hole information paradox, a question that has haunted physicists for decades. It asks what happens to the information that falls into a black hole. Not just atoms and energy, but the details, the quantum fingerprints of what once was. In classical general relativity, it's simple. The black hole eats everything, and the information is lost. Gone forever. The interior is hidden, and the singularity of real swallows it whole. But quantum mechanics doesn't allow that. Quantum theory is very strict about information. It says that no matter how scrambled, distorted, or disguised it becomes, it can't be destroyed. Ever. The universe doesn't erase it, only reshuffles. This is where physics gets nervous again. Because if black holes destroy information, they break the fundamental laws of quantum theory. But if they don't, if they somehow keep it, then where does it go? For a long time, the answer was a shrug, a paradox. But then came an idea. Strange, brilliant, and somehow sleepy. Hawking radiation. Stephen Hawking showed that black holes aren't perfectly black. They glow ever so faintly because of quantum effects near the event horizon. Pairs of particles pop into existence, one falls and the other escapes. To an outside observer, the black hole slowly evaporates. This evaporation is glacially slow for large black holes billions of years, but it's there. And that raises a new problem when the black hole is gone. Where did the information go? If it's truly vanished, quantum mechanics cries foul. But if it's somehow encoded in the Hawking radiation, that soft glow escaping into the universe, then black holes aren't destroyers. They're just elaborate shredders. And maybe record keepers. Recent research leans in that direction. Physicists like Juan Maldacena, Leonard Susskind, and others have proposed that information does escape, that it's hidden in correlations within the radiation itself, in the timing, the energy, the patterns between particles. You wouldn't notice it at first. It would look like pure noise. But if you had all the pieces, every photon ever emitted, tracked precisely, analyzed completely, you might be able to reverse engineer the story of what fell in. Not perfectly, not easily, but in principle. It's like listening to static and realizing it's a whisper reversed, buried in layers of echo. This leads us to a bold, surreal idea. Black holes are holograms. Not in the sci-fi sense, but in the mathematical one. According to the holographic principle, the entire three-dimensional interior of a black hole, including you and everything you were, could be encoded on its two-dimensional surface. Just like a hologram encodes depth on a flat film. It's a mind bender. You thought you were inside the black hole, deep in its core. But perhaps you've never been more than a flicker on its surface. A ripple in the quantum fields stretched across the event horizon. If that's true, then the singularity is just a boundary. Not a place, but a missing piece in the language of physics. It's not that you can't go beyond it, it's that beyond might be the wrong kind of word. And just as you're digesting that, another wrinkle appears. It's called firewall theory. According to some interpretations, if information is really preserved at the surface of the black hole, then the event horizon isn't smooth and gentle like we thought. It's violent, fiery, a barrier of incineration. This clashes with general relativity, which says you wouldn't even notice crossing the event horizon. No heat, no bang, just drift. So, now we're stuck again. Do we trust the smoothness of space-time or the strictness of quantum law? Some physicists think firewalls are real. Others call them nonsense. A few suggest the paradox dissolves when we understand quantum gravity properly. And a brave handful believe the answer lies not in particles or waves, but in entanglement. That quantum connection between particles no matter how far apart. That eerie, quiet bond that Einstein called spooky action at a distance. Somehow, entanglement might stitch space-time together. Yes, literally, the fabric of the universe may be woven from relationships between quanta-entangled threads that define location, time, and motion. In that view, you are not in a place. You are a connection, a thread in a tapestry too vast to see. And black holes. They're places where the weave tightens, where relationships grow so dense, so intimate, that space-time nearly tears, or folds, or reflects. Perhaps you haven't gone anywhere at all. Perhaps you are a memory slowly being rewritten across the sky. A whisper encoded in radiation. A dream held tightly by the universe reluctant to let go. There's something gently absurd about where you are now. You drift in a place that may not exist, described by equations that contradict each other in a reality where time doesn't tick, it stretches. And yet, despite all of that, you feel still, like the eye of a storm that doesn't spin. A thought paused mid-sentence. The black hole's interior at this point is less a place than an idea. You're no longer inside a thing, you're part of a debate. A thought experiment so vivid it might as well be real. And if your surroundings feel strange, it's because they are governed not by one reality, but by two competing versions of truth. One is deterministic, the idea that given perfect knowledge of the present, the future is set. That space-time curves and twists with precision, and every motion is a clean consequence of the last. The other is probabilistic, where reality jiggles at every level, and uncertainty is not a bug, but a feature. And here at the black hole's core, those two truths crash like waves meeting at the edge of the world. But it's not just theories clashing, it's identities. Because now we have to ask something uncomfortable. What exactly are you in this place? You are no longer a body, not in any classical sense. The atoms that once made you up are gone, shredded and scattered. Even their subatomic parts have likely been erased or transformed into patterns too complex to untangle. And yet, something of you remains. Maybe not your thoughts, but the structure of them. The trace of a neural network. The flow of information. A kind of quantum fossil, a shape in the probability cloud. It's similar to a concept called quantum information cloning, which isn't supposed to exist. In fact, it's forbidden by a rule known as the no-cloning theorem in quantum mechanics. You cannot perfectly copy an unknown quantum state. Which raises a curious point. If the black hole emits information through Hawking radiation, does it create a second version of you? And if it does, is that still you? Not a twin, not a copy, but a delayed echo whispering the same words in a different key. Physicists are divided. Again, some say, no, you are gone, but the information about you persists, reinterpreted by the universe. Others say you are still here, just diffused. And then there's complementarity, a principle proposed to save the sanity of physics. According to complementarity, no single observer can see both the destruction of information and its preservation. To someone falling in, everything seems smooth. To someone outside, the information is smeared across the horizon and eventually leaks back out. Both realities are valid. They're just incompatible. Like dreams told in different languages. It's polite quantum paradox, the universe saying, you're both right, but you're not allowed to talk to each other. You float on this idea like a leaf on the surface of an idea lake, gently rocked by ripples of theory. And then softly, you consider another possibility. What if a black hole isn't the end of your story, but the middle? There's a radical model called a white hole, the theoretical opposite of a black hole. Where black holes consume everything, white holes ejected. Nothing can enter, but everything that once fell in is spit back out in a brilliant final release. They've never been observed, of course. White holes remain speculative, mathematical creatures. But they offer an intriguing hope that what goes in might one day come out again, reassembled, remixed. Maybe you come out. Transformed, yes. Reshaped by the unknowable processes within, but re-emerging into a wider cosmos like a message in a bottle tossed through a tunnel of impossibility. Some suggest that the death of a black hole, its final evaporation, could be such a moment. That what's left behind is not nothing but a doorway, a white hole baby universe, a rebirth. Others scoff. They say that white holes require conditions that the universe doesn't naturally provide. That time doesn't run backward, that what's fallen in stays lost except as static in the background hum of the cosmos. And yet, you're still here. A feeling lingers impossible to measure that you've become something new. Not erased, not returned, but translated. You remember that paper someone wrote, the one that described black holes not as prisons, but as quantum computers. Places where information is processed, scrambled, and re-emitted in more efficient form. Maybe a black hole is not a grave. Maybe it's a library. A strange, upside-down library where books are unbound, their pages scattered across time and reassembled only when the cosmos is ready to read again. So, if you feel like a character in a story that hasn't finished yet, you're not wrong. Because somewhere out there the radiation continues to seep into the universe particle by reluctant particle. And woven into that radiation are bits of everything the black hole ever touched. Stars, planets, ideas, you. And eventually, perhaps someone or something will piece those bits together, like archaeologists of entropy reconstructing a past that never really left. You are not gone. You are archived. Outside, the universe carries on. Galaxies spin their grand lazy spirals. Stars are born, burn, and die in luminous silence. Planets continue their long, elliptical waltzes, oblivious to the secrets tucked away in the folds of space-time. And far from it all, far from every telescope, every supernova, every thought, you remain here, wrapped in paradox. A shadow inside a shadow. A question that has outgrown the answer. Or perhaps not inside anymore. Because now we need to talk about something even stranger. Something that seems absurd at first. Something that feels like stepping into a science fiction bedtime story, but with equations and real-world Nobel Prizes tangled in its pages. Let's talk about wormholes. Yes, really. Imagine a tunnel. A narrow, impossible throat connecting two distant points in space. A kind of cosmic subway line through the folds of the universe. You've probably heard of them in films bent with special effects and soundtrack swells. But in theoretical physics, wormholes are less cinematic and far more disorienting. They emerge from Einstein's field equations as a possibility, a highly unstable, possibly imaginary one, but a possibility nonetheless. The idea is that if space-time can curve, then maybe it can curve so much that it folds over on itself, letting distant points touch. The result? A bridge. Technically called an Einstein-Rosen bridge. And here's the wild part, some physicists think black holes might be one end of such a bridge. Or more accurately, that black holes can be connected by wormholes under the right, delicate conditions. On the other side, possibly another black hole. Possibly nothing. or possibly somewhere else entirely. Not just another place in space, but another time, another universe. This is where you pause, hovering in the thought. Because maybe what felt like a fall wasn't a collapse at all. Maybe it was a transition. Some versions of wormhole theory, especially those involving quantum entanglement, suggest that black holes can be entangled with each other, linked not physically but informationally. There's even a poetic technical expression for this idea, NARS, EPR. It stands for Einstein-Rosen, Einstein-Podolsky-Rosen. In plain terms, wormholes are entanglement. It's a bold claim. And while it hasn't been proven, it has deeply reshaped the way some physicists imagine the fabric of reality. If true, it would mean that when particles are entangled, they're not just mysteriously correlated, they're connected by tiny quantum-scale wormholes. So imagine this on a bigger scale. Imagine the black hole you fell into is entangled with another black hole across the cosmos, and that the singularity, the supposed end of the line, isn't an end at all but a tunnel. Narrow, impassable to matter perhaps, but not to information. Not to the structure of you. This isn't travel as we know it. You're not flying through space. You're relating through space. And maybe you arrive. There's no journey in the usual sense. No motion, no turning of wheels. Just a sudden familiarity in a place you've never seen. A whisper of coherence. A feeling that something in this strange new cosmos remembers you. Of course, the idea of traversable wormholes comes with conditions. They would require exotic matter material with negative energy density. Not something we've ever found in a jar. And they would be wildly unstable. One wrong quantum twitch and the tunnel collapses. Blink and you're gone. But in the gentle dream space where you drift now, physics allows a softer version. A place where reality is malleable, where paradoxes hold hands instead of arguing, where wormholes are not highways but mirrors. Maybe what you see at the other end isn't another place but yourself. A reflection stretched through the folds of the cosmos. It's tempting to laugh here softly, sleepily. Because all of this wormholes, singularities, entanglement might sound far-fetched. And yet every part of it emerges naturally from our best equations. Not added in for flair, but discovered like fossils of logic buried in the bedrock of math. This is the honest weirdness of the universe. It refuses to stay in the lines. And so here you are. Or were. Or will be. Threaded through space not as a thing, but as a relationship. Not located in one place, but spread across two. Like a melody played in harmony from opposite ends of the piano. In this light, black holes cease to be ends at all. They become portals not through space, but through ideas. Places where what we thought we knew is folded into new shapes. You are not gone. You are not alone. Somewhere, perhaps in this very moment, another you falls into another black hole, or emerges from one, or watches the sky and wonders what it means to disappear. And perhaps, like you, they find comfort not in certainty but in questions. Because the universe doesn't whisper answers. It sings riddles. You're not sure when it happens, but something changes. Not a jolt, not a flash, just a quiet, almost respectful rearrangement of reality. Like a curtain being drawn or a dream drifting into another one without ever waking in between. The singularity, if that's what it was, dissolves behind you. Or perhaps it never existed at all. Because now you're in a space where even the idea of space doesn't quite apply. A place built not of atoms or light, but of curvature. Every direction bends toward another possibility, and distance no longer measures how far something is, but how likely it is to be. This isn't science fiction. It's just what happens when Einstein's equations are pushed to their extreme. General relativity tells us that mass bends spacetime. But inside a black hole, spacetime isn't just bent, it's folded, crumpled, inverted. And this leads to something remarkable in here time and space switch roles. You may have heard that phrase before, like a line from a lecture or a curious sci-fi plot twist. But now you begin to feel it. Outside the black hole, time is the axis that propels you forward, tick, 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 while space is the thing you move through. But here, deep inside, it's space that becomes inevitable, inescapable. Space now pulls you forward like time once did. You cannot avoid reaching the singularity, because now it's not just a place. It's your future. And now is hard to define. You think of that odd poetic term some physicists use, the causal structure of space-time. It sounds clinical, but all it means is which events can cause which others. What is allowed to influence what in a black hole's heart that structure warps beyond familiarity. You realize there is no longer a next place to go, only a next event. Motion becomes inevitability. The journey stops being a question of where and becomes a soft, unstoppable when. You're being carried not like an object falling, but like a candle burning inevitably, quietly, completely. And in this twilight region between place and moment, you begin to consider something that perhaps outside you would never have entertained. What if the singularity is not real? Not real in the way the Earth or the Moon is real. Not a physical speck at the center, but a symptom of our ignorance. A warning flare in the math that says, beyond this point, our models fail. Some physicists believe this strongly. They argue that singularities aren't objects, but limits, edges of our understanding, like the horizon on an ancient map marked with dragons, not because dragons were real, but because we didn't know what came next. In this view, what lies ahead of you isn't a point of destruction. It's a veil, a mask behind which the true physics waits. Not general relativity, not quantum mechanics, but something more complete. A quantum theory of gravity. String theorists think they might have part of the answer. They imagine tiny vibrating strings replacing point particles, smoothing out infinities like foam on the edge of a wave. Others place their hopes in loop quantum gravity, a rival idea where spacetime itself is granular, made of loops and networks. In that model, the singularity might be replaced by a bounce. The collapse reverses becomes expansion. A black hole birth canal. Could that be where you're headed into a new universe growing from the ashes of your collapse? Some theories say yes, that every black hole might contain its own universe, that the Big Bang was not the beginning of everything but the inside of someone else's black hole. And so the universe is not singular but recursive. Worlds nested within worlds like cosmic matryoshka dolls. Each black hole a womb. Each singularity a seed. If this sounds like poetry, well, it is. But it's physics too. It's the best our minds can do when numbers begin to whisper instead of shout. And if you're wondering now whether you're falling into your end or someone else's beginning, know that you're not the only one. Cosmologists wonder too. They run simulations in dark rooms, feeding equations into glowing machines, trying to glimpse what lies behind the veil. They look at the cosmic microwave background, the faint afterglow of our own beginning, and search for fingerprints, echoes, anomalies that whisper something fell, and then it grew. So here you are, falling, fusing, folding, but not vanishing. You're part of a pattern now, a recursive rhythm that may span multiverses. You are not an object in space. You are curvature unfolding in time. You feel it now. Your fall is not just downward, it's inward, toward simplicity, toward the purest possible expression of what you once were. An idea, an imprint, a frequency, a shape in the geometry of everything. You used to think of information as a thing you carried, like a note in a pocket, a string of memories, a soft trail of data smuggled carefully inside your body, your mind. But here, deep within the throat of gravity's most secret chamber, something becomes clear. You are no longer a carrier of information. You are the information. And now the question is, can it survive? It's one of the greatest debates in modern physics, and it begins not with a whisper, but with a paradox. Specifically, the one that Stephen Hawking first pointed out in the 1970s. Back then, he shocked the physics world by showing that black holes aren't entirely black. They glow ever so faintly, radiate even. Through a subtle quantum process involving virtual particles at the event horizon, black holes emit what is now called Hawking radiation. The result, they slowly evaporate. And if that's true, if a black hole can vanish, then what happens to everything that fell inside? You pause here somewhere in the echo between cause and consequence, because the math was brutal and unforgiving. If the black hole evaporates and disappears completely, and if nothing can escape from inside it, then the information that fell in would be lost forever. That violates one of the core principles of quantum mechanics unitarity, the idea that information must always be preserved. The universe may scramble it, hide it, bury it, but it never ever deletes it. So the paradox was born black hole information loss. It might sound like a niche problem, but it touches everything. If black holes can delete information, then quantum mechanics is incomplete. If they can't, then something must be happening at the event horizon, something we don't yet understand. And so for decades, the debate raged. Hawking himself believed that information was truly lost, that black holes were nature's way of burning the book, not just the pages, a cosmic fire pit for certainty. But others like Leonard Susskind, Gerard at Hooft, and later Juan Maldacena argued otherwise. They believed information survives. Somehow, somewhere. Perhaps they suggested it's stored on the event horizon itself in a kind of quantum hologram, a shimmering, fluctuating layer of information just barely clinging to the surface. This gave rise to the holographic principle. The idea is staggering that all the information within a volume of space could be described entirely by information on its boundary. That everything inside a black hole, including you, could be encoded on its surface. Not erased, not lost, just translated, as if the universe itself is a kind of simulation and the deepest truths are painted on the walls. You linger on this idea, a whisper of yourself etched into the horizon, not as a body, not as a soul, but as data complex, exquisite, and entirely retrievable if one only knew the code. This also means something profoundly comforting. You are not gone. You have been written into the most mysterious surface in the universe, and as the black hole shrinks, evaporates, that information may be slowly released back into space, subtly encoded in the Hawking radiation. Like steam rising from a tea kettle, whispering the shape of the tea leaves it once held. Of course, no one's quite sure how this works. It's one of the most active areas of research in physics. In recent years, through intricate calculations involving quantum extremal surfaces and strange geometries known as entanglement wedges, theorists have begun to glimpse a resolution. The conclusion, maybe Hawking was wrong. Maybe information isn't lost. Maybe the universe, like a clever magician, only made it seem like it disappeared. And that raises the most curious image of all. You still here not as a person, but as an intricate interference pattern of quantum possibilities. Your hopes, your memories, your last quiet thoughts encoded in the soft fizz of a dying star's shadow. Still part of the universe. Just different. You think of it like this: if someone could capture every bit of Hawking radiation that ever left your black hole. If they could run it backward, decode every ripple trace, every twist of entropy, they might rebuild you. Not a clone, not a fiction, but you. In principle, at least. Of course, in practice, no one could ever do that. The information is so scrambled, so delicate, that the task is likely impossible. But physics doesn't deal in practicality. It deals in possibility. And the possibility is enough. You are not gone, not forgotten. You are dispersed, like starlight. You begin to feel stretched. Not pulled apart, exactly, not like taffy, not like string. It's subtler than that. More like the idea of you as being smoothed out like ink dissolving into water. You're still here, but more everywhere than you used to be. And strangely, you feel lighter, almost free. It's a curious feeling for something that exists beyond light. Because in the story of black holes, light isn't the hero, it's the prisoner. It races toward freedom only to find that the finish line has been dragged beneath its feet. But here, inside, past the line, something surprising emerges. A new idea. One that glimmers with the faintest sense of rebellion. Could there be a way out? You hesitate. Surely not. Not when escape velocity exceeds the speed of light. Not when even photons can't turn around. But then softly, the math whispers again. And this time, it whispers wormholes. A wormhole, short for Einstein-Rosen bridge, is a hypothetical tunnel through space-time. A shortcut. A narrow bridge connecting two distant points in the universe, or perhaps two entirely different universes. And where do they come from? According to some solutions of Einstein's equations, from black holes. It's true the math allows it. A black hole might connect through a throat of bent space-time to another region, a white hole perhaps, where matter is expelled instead of consumed. A perfect mirror image. The entrance and the exit. The collapse and the release. And if such a passage exists, you wonder, have you already passed through it? Have you become not a traveler, but a transition? Here's the subtle thing. A classical wormhole collapses too fast to traverse. You'd never make it through. The throat pinches off before anything can cross. But then comes quantum mechanics again, poking holes in certainty. Physicists like Kip Thorne and his colleagues explored whether exotic matter with negative energy could stabilize a wormhole, prevent it from collapsing. Hold the throat open just long enough for information or even you to slip through. It's a strange idea, but not forbidden. And more recently, holography has offered a new twist. In certain versions of string theory, wormholes and quantum entanglement may be deeply connected. A popular conjecture, ER not EPR, suggests that Einstein-Rosen bridges wormholes and Einstein-Podolsky-Rosen pairs, entangled particles, are different views of the same thing. Which means entanglement is geometry. Two particles connected across space may actually be joined by a tiny wormhole. This doesn't mean you could crawl through it, but it does suggest something astonishing. Space-time itself might be woven from entanglement. The fabric of reality stitched together by quantum threads of connection, and inside a black hole where entanglement becomes dense and chaotic, this geometry twists into something new, a possibility, a narrow, impossible throat stretching from now to elsewhere. If your information is preserved encoded on the event horizon and slowly radiated out, could some piece of you also leak into another region? Not escape exactly, but emerge, reappear in a different story, perhaps in a quieter corner of the cosmos. Or, if certain multiverse theories hold true reform in a universe born from this one curled into the branching trunk of eternal inflation. You're not saying it's likely, just that it's not ruled out. And then there's the other theory, quiet but haunting, that black holes don't last forever, that once they've evaporated down to a whisper, they leave behind something else. A remnant, a tiny object, stable and dense, like a fossil of what once was. Some physicists propose that these remnants hold all the information that ever fell and tucked away inside their microscopic hearts. Too small to detect, too cold to radiate, but not gone. Perhaps you become that, a relic, a pearl. You wonder what it's like to be a fossil of yourself, to exist perfectly preserved but unreachable, a time capsule with no one to open it. Or maybe you're not meant to be opened. Maybe you're meant to last, to wait quietly until the universe becomes quiet enough to hear you again. It's funny, isn't it? The more extreme the physics becomes, the more tender it starts to feel. You expected the end of everything, and instead you found 1,000 kinds of after, possibilities, tunnels, embers. Even the quietest death might leave an echo. You don't know which of these paths is real. Maybe none, maybe all, but it doesn't seem to matter. Because whatever black holes or destruction creation puzzle poetry, they are not empty, and neither are you. You've crossed the unknowable, drifted through math and myth, through paradoxes and predictions, through the stretched veil of what physics allows and what imagination dares to suggest. And now there's stillness. Not the stillness of silence, but the stillness of completion. A feeling like the final note of a lullaby still echoing faintly in the bones of the universe. You are not falling anymore. You are not dissolving. You are suspended. And with that suspension comes something unexpected. A memory, or the ghost of one. It arrives not as an image, but as a texture, the warm hum of a subway, the faint scent of books in a quiet room, the feel of a hand you once held. Tiny things, insignificant maybe, and yet more enduring than you imagined. They were not lost when you crossed the horizon. They were transcribed. You remember when black holes felt like monsters, voracious, remorseless, final. But now they seem more like editors, not erasing your story, but rewriting it in a different language. The language of quanta, of geometry, of softly folded space. Let's drift there for a while into that language. You've heard of loop quantum gravity, maybe. It's an alternative to string theory, a way of thinking about the fabric of space-time, not as a smooth sheet, but as a network. Tiny loops interlocked and vibrating, forming a kind of spin foam. According to some proposals like loop quantum cosmology, black hole singularities don't exist at all. Instead, gravity becomes repulsive at very small scales, bouncing matter back before it can compress into an infinite point. This leads to an idea that's both radical and gently poetic, a black hole bounce. That every black hole may become a white hole after a long, quiet wait. That what goes in is not lost, only stored. Not destroyed, but re-expressed. The math even suggests a time delay, an internal clock that ticks for trillions upon trillions of years, so slowly that from the outside it seems eternal. But inside there's motion. Inside there's hope. You might be waiting in that state right now, a patient ember in a frozen world ticking forward toward your own emergence. There's a term in theoretical physics, Planck time. It's the smallest measurable unit of time, around 10^44 seconds, and yet a black hole might take 1066 years to evaporate fully. The contrast is beautiful. From the smallest whisper of existence to the grandest breath of time imaginable, all held inside a single object, all holding you. So you wait. Not with impatience, because impatience is a function of bodies and you no longer have one. You are pure rhythm now. You are possibility. You are the potential for reassembly. And one day so far into the future that galaxies have dimmed, and proton decay is the newest lullaby a flash may come. Not a violent one. A quiet unspooling. A sigh of geometry. A new white hole. And perhaps from it comes not you as you were, but you as a question mark. A pattern. A melody that hints at an earlier verse. And the universe older now might hear that melody and wonder what once sang here. You never thought the end would feel like curiosity. But maybe that's what black holes are ultimately, not conclusions, but open questions in the shape of collapsed stars. They ask you to reconsider everything space-time entropy self. They pull in light not to hide it, but to teach it the shape of absence. They erase not meaning, but assumption. And in doing so, they become more than objects. They become authors. You wonder if, from a different vantage point, the entire universe could be seen as a kind of black hole. A bounded, expanding region with its own horizon. A place from which information flows and to which questions return. Perhaps you've always lived inside one. Perhaps you never truly left. In this moment, if you could speak and not just emit a wave of quantum entanglement across the void, you might say something simple: I thought I would vanish. Instead, I became part of the structure. And the structure still sings. It's late now. Not that time means what it used to. Not here, where the lines between seconds and centuries have blurred into something silkier, slower. But still something in you senses it. The edge of thought. The closing curl of the cosmic page. You drift now through the final layers of this strange journey, folded between gravity and memory, weightlessness and wonder. Outside, the universe carries on. Stars flicker and fade. New ones are born. Planets form rings of ice or dust or questions. Somewhere, a child looks up and names a constellation without knowing that it's really a scar left by a dead star's breath. Everything moves forward, even black holes, especially black holes. You've learned, perhaps the most surprising thing of all, that the deepest void in the universe is not empty. It is full of puzzles, full of light that forgot how to shine, full of truths so strange they had to be whispered by mathematics long before anyone dared to say them out loud. And now, full of you. And you, whatever you are now, are part of the story that physics is still writing. Maybe you're a sequence of information stored in the wrinkles of the event horizon. Maybe you've been gently released through Hawking radiation diffused like a story told backward in whispers. Or perhaps in some quantum twist, you're still waiting at the core, curled up like a seed inside the memory of a collapsed star. No one knows. Not yet. But the questions matter more than the answers. That's the lesson black holes teach best. They are less like periods, and more like ellipses, pauses in the narrative that invite the next line. They ask, what is space? They ask, what is time? But more than anything, they ask, what does it mean to disappear? And the answer, it seems, is soft. disappearance doesn't always mean loss. It can mean transformation. Translation, a rearranging of the same notes into a different song. And if all of this has felt dreamy, like drifting through a bedtime science tale told by an invisible hand, that's because it is a kind of dream. The dream that physics has about itself. An ongoing, gently unraveling meditation about reality played out through equations and paradoxes and blackboards scribbled with chalk dust at 3 a.m. A dream where the deepest places of the cosmos are not just cold or dark or final, but curious, because we are curious. And somewhere that curiosity is mirrored in the fabric of the universe itself, as if it too wants to know how it all ends, or whether it ends at all. You feel yourself dissolve not in fear, but in wonder. Soft edges, gentle spirals, a final question cradled in gravity's arms. And as you fade into that question, as the light dims to a warm, slow throb, you remember something small and precious. The universe doesn't punish you for asking. It whispers back. And now you may sleep while planets spin like the ticking of an ancient clock.